Lesson 5.1 begins with monomials, and monomials is an expression, a single expression, so they don't have addition or subtraction with them. Mono meaning one, so they just have one term, one part to it, which will be different than when we get to polynomials. So to simplify an expression containing powers, we have to rewrite it without parentheses or negative exponents. So it's really important to know what the directions mean. So when the directions say simplify, basically you are going to combine as many like terms under multiplication, addition, subtraction, division as you can to simplify it down to hopefully a single term in the case of monomials or fewer terms in case of polynomials. So our orders of operation are always important and paying attention to things. So if we are simplifying the quantity 3x cubed y squared times negative 4x squared y to the fourth, our 3 and our 4, because this is straight multiplication, we know that the order that I multiply does not matter. And so I can switch multiplication up and I can reorder it to make it easy for myself. So I can put the 3 and the negative 4 together to come up with negative 12. Now this example is showing you the very, very long way of expanding. X to the third means there are 3 x's. Y to the second means there are 2 y's. When you multiply, you get powers on variables. When you add, you get the coefficients in front. So if I had 3 x's in the first one and I have 2 x's in the second one, that means I have 5. And if you go back to your geometry, remember our exponent rules that like bases being multiplied means I add my exponents. And so this whole thing boils down to negative 12 x to the fifth y to the sixth. So for any real number, this is the rule, the product of powers. If I am multiplying like bases, I add the exponents. So for example, if I have m to the seventh times m to the fourth, I really have m to the 7 plus 4, which is m to the 11. And that is a review concept. Now if when we're multiplying we add, if we're dividing, we are going to subtract. Think about opposite operations and undoing. So if I have, for example, x to the 7th over x to the 4th, the long way, 5, 4, 7, we would go through x divided by x cancels, x divided by x cancels, x divided by x is 1, x divided by x is 1, and it would leave x to the third. But that's a lot of work. So instead, we can just write that. Now remember, if our denominator is bigger, there is that negative, please move me, rule. So that's what we've got going on here. So simplifying expressions with division. So p to the third divided by p to the 8. So when you subtract, you get a negative. And remember, the negative sign is like a sticky note that says, please move me. So it wants to go from living in the numerator to living in the denominator. And if you think about doing it the long way, I had 8 in the denominator to start with. So when I cancel the 3 off, the 5 that are left are in the denominator. Also remember, if I start with something like 1 over a to the minus 3, that still says, please move me, and it wants to become a to the third in the numerator. We don't need to write the over one, but if you need to remember, that's fine. But remember, once I move it, then I take that sticky note off, that direction that said, please move me. Don't confuse negative a to the second. That negative is like a negative 1 on here. So make sure that the negative that you're dealing with when you move it is only in the exponent position. So we can use the quotient of powers property and the definitions to simplify lots of expressions. So another rule, and if you look at this example, y to the fourth divided by y to the fourth is y to the 0. But if you think about doing it out the long way, what happens, everything cancels, and it's not that things disappear and I end up with 0. Remember, y divided by y is 1. What's 1 times 1 times 1 times 1? It's 1. And so the rule, and this is the one you should get really excited about, is anytime you see an exponent to the 0 power, it's 1. So for example, if I had something like 5x to the 2nd, y to the 7th, z to the minus 3, all to the 0 power, notice where the parentheses are, that big mess equals 1. And that's all I have to worry about. So just quick review, these are the rules that you need to remember. Power to a power, we multiply. So for example, if I have x to the 5th to the 3rd, that's saying I have 3 groups of x to the 5th, which is really x to the 15. That's that one. Power of a product, that's the distributive property. So if I have a to the 3rd, and then we can start combining them, b to the 2nd, all raised to the 3rd power, that's saying I have 3 groups of this thing, so I can make that power to a power rule. I have a to the 9th, b to the 6th. So I put that 3rd power on both of them, and then it also becomes a power to a power problem. And that's how we start layering. Power of a quotient, that is going to happen exactly the same way. If I would have a fraction like this, I could write 4 to the 2nd over x to the 2nd, or 16 over x squared. That power goes to both parts of the fraction. Always pay attention to where your parentheses are. Here's a big caution, or a big careful. Notice the difference between 2x cubed is not the same as 2x cubed. In the first one, this gets distributed, so I have 2 cubed x cubed, which is 8x cubed. In this one, the cube is only on the 3 because there are no parentheses. So those parentheses are very crucial to clarifying what is being raised to powers and what is not. So simplifying expressions. Individually, these rules are pretty easy. When we start to layer them, multiple rules within the same problem, you just have to work through it step by step. Don't skip steps. Show your work, and often there's more than one way to do things. But our PEMDAS rules of working inside parentheses first and then to outside still apply, so I always check inside first. So in example 1, a cubed, there's nothing I can do. This is a power to a power, so I multiply. Here in B, I check. There's nothing I can combine or simplify inside. This is also a power to a power, so the 5 exponent is going to go on everything. Negative 2 to the 5th, p cubed to the 5th, s squared to the 5th. These are power to a power rule, so I multiply, and I end up with this as my final answer. C is a fraction to a power, and so again, this gets put not only on the x, it also goes to the 3, and it also goes to the 4. So I can split it first to the numerator, negative 3x, the quantity to the 4th, all over y to the 4th. Then this one is going to get distributed, and then I work my math out, and I end up with 81x to the 4th over y to the 4th. Now D introduces a negative, and there's a couple of ways to handle the negative. First, you could distribute it as a negative, which is probably what I would do. A to the negative 3 over 4 to the negative 3. And then I would say, please move me. And then I would write 4 to the 3rd over a to the 3rd, which is 64 over a cubed. And you will get the same answer. So again, you can do them in whatever order makes more sense to you in most cases. So we can just continue to layer and make them a little bit more complicated every time. So when I look at negative 2x to the 3n over x to the 2n y cubed all to the 4th power, you could simplify inside first and then to the 4th, which is probably how I would do it, which is method 2. Simply because if I can make this simpler first before I go to the 4th power, I can usually do more of it in my head. But as you can see, no matter which way you do it, you end up with the same answer. So method 1 says first they distribute the 4th power to all of the pieces. Then I have power to power, so negative 2 to the 4th becomes 16. X to the 3n to the 4th becomes x to the 12n. X to the 2n to the 4th becomes x to the 8n. Y cubed to the 4th becomes y to the 12th. Then I have like bases of x's across a fraction bar, which means I subtract them, and I end up with 16x to the 4n all over y squared. Now, like I said, I would probably simplify in here first, and so I see those like bases of x, and I'm going to go ahead and subtract those first. When you do that subtraction rule, it always goes to the numerator, and then you may have to handle a negative after that, but you always move it up to the numerator to do the subtraction. And so you can see I get negative 2x to the n here after I subtract. 3n minus 2n is 1n. The y cubed is the same. Then I can distribute this 4, and I end up with 16x to the 4n all over y to the 12th. Now, another related idea that you've seen before is scientific notation, and this is where you kind of boil your numbers down to a shorthand, to a more condensed, tighter notation, because really to have all of these commas and all of these zeros can make it very difficult and kind of error prone. So the base number always has to be between 1 and 10. So basically you look at this and say, how many times do I have to move my decimal place to get it so that I have a number between, a leading coefficient between 1 and 10? Well, I had to move it 1, 2, 3, 4, 5, 6 times. So really what I'm talking about is 6.38 times 1 million. Well, 1 million could be written as 10 to the 6th, and I always think about those having to move your decimal place. So 6.38 times 10 to the 6th is your scientific notation. Remember, positive powers, you get bigger numbers. Negative powers, you get smaller numbers. Okay? So negative is like moving something to a decimal or a fraction. Positive is going to be making it bigger. If I start with something like 0.000047, I have to move my decimal place 1, 2, 3, 4, 5 places to get that number between 0 and 10. But because I need a decimal, that 5 places is a negative exponent. So the 10,000th place, so 1 over 10,000, 1, 2, 3, 4, 5, and then that becomes 10 to the negative 5th. If you think about converting this to a negative exponent. And now I have a nice tight definition. So just a couple of quick examples. These are going to work exactly the same as our other ones. You're going to pull your lead coefficients out, multiply those together. Then you're going to use your exponent rules to take 10 to the 5th times 10 to the 7th, which means you add the exponents to get 10 to the 12th. The only place you need to be worried is if for some reason that number becomes bigger than 10, then you'll have to do another power of 10, or if it becomes smaller than 1, you'll have to bump your powers of 10 to meet that criteria. So if I have 2.7 and 3,